Hello everyone, welcome to Geophysics Academy. Today's class we are discuss the Bode's law. This is the very good law which are basically express some distance of the planet from suns. हम लोग उस बेसिक लॉ के बारे में आज का क्लास में डिस्कशंस करने वाले हैं. तो जितना इन दिस लाइव क्लास में आप सबका वेलकम है और आप जितना हो सके इस लाइव क्लास को आपका फ्रेंड और दोस्त के साथ इसको शेयर कीजिए और ज़्यादा से ज़्यादा लाइक कीजिए, ठीक है. क्योंकि हम लोग हर संडे इस यूपीएससी जियो साइंटिस्ट एग्जामिनेशन के बारे में हम लोग मेंस का जो पेपर 1, पेपर 2, पेपर 3 है, इसके ऊपर हम लोग एक लाइव क्लास लेने वाले हैं इस चैनल में. तो आपको इस चैनल में बहुत ही बेनिफिट होने वाले हैं दोस्तों. दिस चैनल इज वेरी हेल्पफुल फॉर योर प्रिपरेशन ऑफ यूपीएससी जियो साइंटिस्ट एग्जामिनेशंस. ओके, we are discuss here geophysics and physics part also. Both part we are discuss here in every Sunday. In the previous class we are discuss some typical type of planet, right? We are discuss the terrestrial planet, jovial planet और ड्रॉप प्लैनेट. हम लोग 3 काइंड्स के प्लैनेट के बारे में बेसिकली डिस्कस किए थे. 3 काइंड को प्लैनेट के बारे में हम लोग डिस्कस किए थे, ठीक है. सो टुडेस क्लास वी आर डिस्कस हियर very famous law, that is the Bode law. So first of all, what is Bode law? Okay, Bode law. Bode's law क्या है बेसिकली, इसके बारे में हम लोग डिस्कशन करने वाले हैं. देखिए, Bode's law is basically give us a empirical relationship or empirical distance between the planet or distance of the planet from the suns. Okay, सन से लेके हर एक प्लैनेट का जो डिस्टेंस है बेसिकली उसको फाइंड करने के लिए बोड in 1772 this law is basically discovered in 1772. Okay, and this is a German astronomer, Johann Bode. Okay, derive an empirical relationship or empirical formula to express the approximate distance of the planet from the suns. ठीक है. So to express Bode law is basically to express the distance of the planet from the sun. From the suns, Johann Bode expressed an empirical relations that is called basically Bode law. So using this Bode law, we are find out a distance between planet and suns. Okay, so Bode law to express this empirical relations, to express the distance of the planet from the suns, derive an empirical relations. Okay, derive an empirical relations. For derive this empirical relations, Bode's first of all assume a series. Okay, first of all assume a series and series of number basically, and that number is created in the following manner. First of all, first number of this series is taken is 0 and the second is 0.3. So to derive this empirical relations, we can Bode assume a number series. Okay, assume a number series, and of the number series, the first number is basically 0 and second number is 0.3 and the rest of the number is basically obtained by doubling the previous number basically. Okay, so basically बोर्ड बेसिकली एक नंबर सीरीज फॉर्म किया था. इस नंबर सीरीज में फर्स्ट नंबर बेसिकली 0 है और जो सेकंड नंबर है दैट इज बेसिकली 0.3 एंड द रेस्ट ऑफ द नंबर्स आर बेसिकली डबल इन द प्रीवियस नंबर. ओके, सो second point, a series of number is created in the following way. In the following way, the first number is 0 and second number is 0.3. Okay, first number is taken is 0 and the second number is 0.3 and the rest is obtained by doubling the previous number. Okay, by doubling the previous number. By doubling the previous number. By doubling the previous number. That is the expressions. So basically the number is number is 0.3 and doubling the previous number, that is 0.6, 1.2, so 2.4, and for the 9 planet we are assume 9 number. Okay, 2.4 and 4.8, 9.6 and 19.2 and also 98.4 and not 98, 38.4, 76.8 and etc. So basically this is the first planet, second planet, third planet, fourth planet, fifth planet, sixth number of planet, seventh, 8, 9. So for 9 planet, the distance of the 9 planet from the suns, to find out the distance of the 9 planet from the suns, he assumes 9 number basically. Okay, and these numbers are assuming the first number is 0, where is the location of the sun, and the first locations of the planet is at a distance. To find out the distance, he assume a number that is 0.3, and for the second planet he assumed the number is doubling on the previous number, and this is the way. Now he also do an algebra. What is the algebra? The algebra is basically he is doing augmented by each number is augmented by 0.4. Okay, now he augmented. Third step is basically each number is then augmented by 0.4. Then the corresponding sequence, is basically 0.4, 0.7, okay, 1, 1.6, 2.8, 3.2, not 3.2, 5.2, 5.2, 10, 10.0, and 19.6, 70, 7.2, etc. Okay, so using this sequence, इस sequence आपको मिला basically. इस sequence से using this sequence or using this series, he can express the mathematical formula of Bode's law. Okay, from this sequence, this is the sequence number 0.4, 0.7, 1, 1.6, 2.8, 5.2, 10.0, 19, 77.2. From this sequence or series, he can express the formula of Bode's law. Okay, formula of Bode's law. So now the mathematical expressions of Bode's law is distance of the nth planet, dn, it's equals to 0.4 for n equals to 1, and also dn is equals to 0.4 plus 0.3 into 2 to the power n minus 2, and n is n is greater than equals to 2. So this is the empirical relations for Bode law. Okay, this is the empirical relations of Bode law. So empirical relations is Bode law is basically 0.4 plus 0.3 into 2 into n to the power minus 2. Okay, here dn is the distance of the nth planet, distance of nth planet from the sun, and this distance dn expressed in astronomical unit. Okay, this distance expressed in astronomical unit, AU, astronomical unit. So this is basically usually known as a Bode's law. This is basically called Bode law. Bode's law. Okay, basically called Bode's law. Now this Bode empirical law for the distance of the planet, now it is placed in graphical form. Now law expressions, that is equals to 0.4 plus 0.3 into 2 to the power n minus 2, and here n is basically greater than equals to 2. Now this mathematical expressions can be expressed in graphical view, and so the graphical view of the distance of the planet from sun is as like it. So now the Bode empirical law for the distance of the planet from the suns, graphical view. So graphical view for Bode's empirical law Bode's empirical law for the distance of the planet planets from the suns. ओके इसका हम लोग ग्राफिकल व्यू देखने वाले हैं बेसिकली. ओके, लेट्स टेक यूजिंग दिस एक्सप्रेशंस we basically plot a graphical view of the distance of the planet. So let us take a graphical view as like it. This is the point 1, this is the point 100, this is the point 100, and this axis is give us the distance of the suns. Okay, distance of the suns, distance of the suns in astronomical unit, distance from the suns, not of the sun, distance from the sun, distance from the suns in astronomical unit. And this axis give us observation distance from the sun. Observation distance from the suns. This is also astronomical unit. Okay, this is also astronomical unit. So the graphical view looks like that. So planets are basically located along the straight lines. The first is the Mercury, second is the Venus, then it's Earth, and then Mars, and then have a asteroid belt or asteroid body. So the asteroid body, and then Jupiter. Okay, then Jupiter, and then a star, then Uranus, Neptune, and then have a Pluto. This is the Pluto, and this is the asteroid belt or asteroid body. So this is the asteroid body. So first is the basically Mercury, and then Venus, and this is the Earth, and then Mars. This is the Mars, and this for Mars, after the Mars, asteroid body are basically present, and before and now after the asteroid body orbit, Jupiters are present. Basically Jupiter. So after Jupiter orbit, star orbit are formed. This is a star, and then Uranus and Neptune, and then Pluto. So these are the basically Bode's empirical law for the distance of the planets from the suns. And first is the basically 0 से लेके 1 एस्ट्रोनॉमिकल यूनिट, इसके अंदर बेसिकली मार्स है प्रेजेंट है, वेनस प्रेजेंट है और अर्थ प्रेजेंट है। देन 1 एस्ट्रोनॉमिकल यूनिट से लेके 10 एस्ट्रोनॉमिकल यूनिट, इसके अंदर बेसिकली देखिए जुपिटर तक है। अर्थ से लेके जुपिटर all are present in between 1 astronomical unit to 10 astronomical unit, and then after 10 astronomical unit से लेके 100 astronomical unit इसके अंदर बेसिकली जुपिटर से लेके नेपच्यून तक है। एंड beyond the 100 astronomical unit, Plutos are basically present. That means Plutos are basically present at a long distance from the suns in the solar systems. So Plutos are basically present at a long distance from the suns. So Plutos, we take a point. Pluto are located at a large distance from the suns. That is beyond 100 astronomical unit in the solar system. So these planets are in the solar system are basically at a large distance from the suns. So please remember. So basically these planets are basically present after the orbit of Neptune's. Okay, after the orbit of Neptune's, basically Pluto are present before the Neptune orbit. तो इस ऑर्बिट के बारे में हम लोग और भी अच्छे से डिस्कशंस करने वाले हैं जब हम प्लैनेट के बारे में डिस्कशंस करेंगे, ठीक है। सो प्लूटो इज बेसिकली प्रेजेंट नेपच्यून ऑर्बिट के बियॉन्ड, बेसिकली प्रेजेंट है। इसको याद रखिए। सो इन बोड्स लॉ, एम्पिरिकल फॉर्मूला जो बोड्स ने बेसिकली डिराइव किया था, इस फॉर्मूला से को finally we are conclude Plutos in the large Plutos is a one type of planet, and that planets are basically located at a long distance from the suns, and its orbits are basically beyond the Neptune's orbits. Okay, it's Neptune's the Pluto's orbits are basically located at beyond the Neptune orbit, and the distance is basically greater than 100 astronomical unit. Okay, so Pluto's orbits are present at greater than 100 astronomical units. Okay, the distance of this Pluto is basically greater than 100 astronomical unit. Okay, so please remember the concept. Now here basically एक बहुत ही न्यू कॉन्सेप्ट ऑलवेज अराइज, दैट इज द एस्ट्रॉयड बॉडी और एस्ट्रॉयड बेल्ट. व्हाट इज द एस्ट्रॉयड बेल्ट? इसके बारे में हम लोग थोड़ा सा एक डिस्कशंस करते हैं. व्हाट इज द एस्ट्रॉयड बॉडी? ओके, एस्ट्रॉयड बॉडी क्या है? बेसिकली एस्ट्रॉयड बॉडी और बेल्ट, यहाँ पे जो एस्ट्रॉयड बॉडी के बारे में बोड्स लॉ predicts, Bodes basically predicts a fifth planet, right? Bodes basically predicts a fifth planet. This is the planet 1, planet 2, planet 3, planet 4, and this is the fifth planet. Okay, so Bode's law is predicts a fifth planet at 2.8 astronomical unit 2.8 astronomical unit from the suns between the orbits of Mars and Jupiter. So Bode predicts another planet, that is the planet number 5, and located at a 2.8 astronomical unit from that orbits are formed between Mars and Jupiter subsequently. It and also found that small planetoids, what are planetoids are basically two types. Planetoids are basically two types. So this asteroid belts are basically from small planetoids. Okay, so small planetoid, that's a asteroid like planetoids. So is asteroid body asteroid body एस्ट्रॉइड बॉडी से और एस्ट्रॉइड बॉडी से दिस इज द फिफ्थ प्लैनेट. इसके बारे में थोड़ा थोड़ा कंसेप्ट डिस्कशंस कर लेते हैं हम लोग. दिस इज द फिफ्थ प्लैनेट. ओके, दिस इज द फिफ्थ प्लैनेट and it's have a distance as 2.8 astronomical unit from the suns and its orbit so asteroid belts or asteroid body. Okay, these have some characteristics. This is a fifth planet. Okay, fifth planet, and its survey distance from the sun is 2.8 astronomical unit. Second point, its orbits it's between its orbits between Mars and Jupiter. Okay, between Mars and Jupiter. And third, asteroid bodies are subsequently formed. Asteroid bodies are subsequently form small planetoids. Okay, planetoids are basically two types. Two type का planetoids basically they are forms. Two type का planetoid basically form. Asteroid like planetoid or comet like planetoid. Like planetoids and comet like planetoid. Okay, These two types planets are basically these asteroid bodies. Okay. So these are the asteroid bodies basically in the solar system. So asteroid bodies are basically Bodes are assumed this is the fifth planet, and it is located point astronomical unit, and basically it orbits between Jupiter, and these asteroids bodies are subsequently from small planetoids. Planetoids are basically two types: asteroid-like planetoid and comet-like planet. इसके बारे में हम कैरेक्टरिस्टिक्स ऑफ प्लैनेट के बारे में डिस्कस हैं, तो हम देखेंगे. ओके, थैंक यू. Sons derive an empirical relations. Okay, derive an empirical relations. For derive this empirical relations,